In this video, we talk about major topics
and what we learned about from the beginning of school in Algebra 1 class.
Expressions!
How to solve expressions is simple. To solve, you must use order of operations. Parentheses, exponents, multiplying, dividing, addition, and subtraction. Always remember, please excuse my dear Aunt Sally. Here's an example of an expression.
Radicals and square roots. The radical symbol, the radicand, and the index make up the radical.
A perfect square would be that 9 is the square root of 81.
This is how to find the square root of a number that isn't an exact perfect square. The first thing you do is find a number that is a perfect square, and then find a number that you can multiply by the perfect square to get the radicand. 4 times 7 would give you 28. So you'd have this. But 4 then reduces down to 2, so the answer would be 2 square roots of 7.
Order of operations.
The first step in order of operations is parentheses and grouping symbols. They can be seen as brackets, parentheses, or braces. An example would be 9 plus 7 in parentheses is equal to 16.
The step after parentheses are exponents. You have to solve for the exponents, so from left to right. So if the problem is written as 4 to the second power, you would have to multiply 4 times 4 and you would get 16.
The third step is multiplication and division. You would do this from left to right. Examples are 16 times 16 equals 256, and 12 divided by 2 equals 6.
The last step is addition and subtraction. You have to add or subtract left to right. And the last step is addition and subtraction. Remember to add or subtract left to right.
This is our full order of operations problem using all the steps. The first step you would do were the parentheses, so you do 9 plus 7, you do equals 16. You would bring the rest of the problem down. The next step you would do would be the exponents, so 4 to the second power would equal 16. You bring the rest of the problem down again, and this just repeats for the rest of the time. And next you do the multiplication and division from left to right. So it's 16 times 16, and you'd get 256. And then you'd have 2 divided by 2 would equal 1. And the last thing you do are the adding and subtracting from left to right. So it's 256 plus 6, you get 262. And the last step is 262 minus 1. And then you would get 261 as your final answer.
Functions is a relation where each input has exactly one output. Characteristics of a function are vertical line tests. For example, if it touches, it's a function. If it touches more than once, it's not a function.
Over here, all of these are functions because the x digits do not repeat. You can use the vertical line test over here because the 2 dots do not touch the line twice.
All of these are not a function because the input repeats. For example, the input of 0 repeats twice in this. And then 2 dots touch the same line in the vertical line test.
Adding and subtracting integers and expressions.
Positive plus a negative will always come out to be the same sign as the bigger number, and a negative plus a negative will always be negative.
For example, we have -6 minus 3, and the yellow circles represent a positive, and the red circles represent a negative. So you would put -6, which would be 3 red circles. Then you would put your sign. Then you put 3 yellow circles. Then you would add the opposite and you would change the sign to a plus sign. And then change the 3 yellow circles to 3 red circles. Then you would add and you would get 9. Then your answer would be negative.
First, you get the x by itself by using the opposite operation, and then you substitute the answer with x.
Example of solving equations. 13 plus x is equal to 25.
The steps you would do is first you would subtract 13 from 13, then 13 from 25 and get x equals 12. And you can check your work by doing 13 plus 12 equals 25.
Ratios and proportions.
Here are 3 ways to write your ratios. For the proportions, you need to have 2 ratios to make it up. You would cross multiply the ratios to get this equation. Then you would divide by 12 to get x on its own side, and then divide 24 by 12, which will be 2. That's how you get your answer.
And the projects we did was the Sydney Harbor Bridge span and the road trip project.
These were our major
Topics.
from Algebra 1 class. I'm Grace Kerr.
And I'm Michaela Rico.
We're
We signing
signing
out. This is period 3, and these are some of the main topics we talked about. I did that. I'm going to switch these two to a negative, to that a negative. Then I'll take 2 of the positives out and combine all of these and got that.
In order of operations, there are 4 steps. The first step is to do the parentheses. The second step is exponents. Third step, multiply and divide left to right. And fourth step is add and subtract left to right.
Examples of parentheses and grouping symbols are those. Examples of exponents and roots are those. Examples of multiplying and dividing from left to right are right there in first, second. Examples of adding and subtracting from left to right is first, second, and third.
An example of this would be 5 plus 4 times 3 minus 2 plus 2 plus 6 with an exponent of 2 divided by 3. That would then change to 5 plus 4 times 1 plus 6 with the exponent of 2 divided by 3. 5 plus 4 times 1 plus 36 divided by 3, then 5 plus 4 plus 36 divided by 3. That would change into 5 plus 4 plus 12, 9 plus 12, and the answer would be 21.
Alright, this is not a function, as when you draw a vertical line, the line will touch all the dots. This is a function because when you draw the line does not touch the dots.
The first thing you would do in this problem would be combine your like terms. So first you would take your 3 and your 2. Since there's a subtraction sign, you would change the 2 to a negative 2. It would become positive 3 plus negative 2, which would give you a positive 1. Then you would combine your like terms with x. A single x is equal to 1x. So you would combine 4x and 1x, and that would give you 5x.
These are the topics that we learned in Algebra 1.
Okay, this is a radical. The whole thing is the radical. The thing that is a radical symbol. The whole number under the radical symbol is a radicand. The index is up here. It will be always, it's like a little exponent type thing. The whole thing is the radical.
If the index is not written, it is automatically a 2.
A radical is a square root of a number.
To help with the square roots, you make a list with pairs.
You have to break up the number if a number on the list equals another number to the square root.
You have to break up the numbers and simplify.
Okay, this is the list. 2, 3, 4, it goes all the way down. This is an example, 24, breaks down into square root of 4 and square root of 6. Okay. And 4, if it looks, it's on the list, and it cancels out into a 2. It does not go into a square root. This is not on the list, and you can't break it down, so you just bring it down to square root of 2 to the square root of 6.
Order of operations. That's just about all that is. Parentheses. Your signs, you have regular parentheses, brackets, and these squiggly lines. Use the rest of order of operations while using parentheses and groupings inside of the groupings. Example, bracket, parenthesis, 3 plus 2, parenthesis, plus 4, bracket, equals 9 inside of that. Exponents tells you how many times you multiply that number by itself. 5 to the third equals 506, and 7 to the sixth equals 10,207. Multiplication. Always multiply from left to right with division. Some signs of multiplication. A times B, A times B beside each other, A times B with a dot. 3 times 3 equals 9, 3x 3 equals 9. To the right with multiplication. The signs, you have the division sign, or it could be written as a fraction. Example, 9 divided by 3 equals 3, or 9 over 3 equals 3. Addition. Do with subtraction, left to right. Really one sign for addition. Example, 4 plus 2 equals 6, 3 plus 7 equals 10, 20 plus 2 equals 2, 20 million and 1 plus 3 equals 20 million and 4. Subtraction signs, only one sign, the regular subtraction sign. A minus B. Do left to right with addition. Examples, 9 minus 3 equals 6, 3 minus 9 equals negative 6.
Expressions are mathematical problems that do not use equal signs.
Example, 13 divided by 9 plus 2.
Consists of numbers, variables, and exponents.
14 to the second plus x equals 4.
A function is a relation where each input has exactly one output. Characteristics of a function are the vertical line test. If it touches once, it's a function. If it touches more than once, it's not a function.
X repeats only one time, and same for this one. This one shows you that 1 only repeats one time, so it does not repeat, neither does 3 or 5. So all 3 equals 6. For this one, same thing, none of them repeats, you're good. This one shows that X repeats multi-times. Same with this one, and this one.
Positive plus positive equals a positive.
Example, 1 plus 1 equals 2.
Subtracting two integers is the same adding the opposite.
For example, positive minus a negative equals a positive is the same as positive plus a positive equals a positive.
Hello and welcome to our open house this year. These are the main topics we've talked about so far in Algebra 2. Any words, Tim?
We've talked about radicals, slope and rate of change, order of operations, properties, x and y intercepts, and graphing lines, real number systems, absolute value, representing relations and functions, and don't forget the almighty inequalities.
Yes, and as you can tell, he did not use a script.
No. Praise the Lord.
Yep.
2, 1.
The real number system consists of all most numbers you can think of, like 1, 2, or 3, or decimals as well as other things like roots and square roots and stuff like that. Now it does in many subcategorizations, such as rational. It's numbers like 2/3 or 1.3 repeating, or 1 or 2 or 3. And below that there's integers, which are negative numbers, positive numbers, and including 0. While whole numbers are numbers that are 0 or positive. While natural numbers are only positive numbers. The irrationals are a bit different, that they're kind of strange in how they work. Like there's the 3 here, you can't actually do that, it's their final thing, it's an irrational number. And like negative square root of 5 is another thing that doesn't really make sense, it's irrational. And actually 1.3 repeating is irrational. What do you write that? Yeah, but that's irrational. As you can see, my friend here,
example.
Yes, he's irrational. See, we point out a mistake. And Sue, yes?
Sometimes square roots are not perfect and you have to simplify them. Simplifying square roots is to break up imperfect numbers. Perfect squares include 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225.
The square root of 4 is perfect, so it would come out to 2, and the square root of 20 is imperfect, so it would be 2 times the square root of 5. Your index will always be 2 for one is not already placed.
Subject is the order of operations. The order of operations are parentheses, exponents, multiplication, division, adding, and subtracting. You can remember this by saying, please excuse my dear Aunt Sally.
You can go from left, well, you always have to go from left to right, and make sure you're always doing the correct steps, because if not, there would be no point.
An example of this would be 1 plus 2 parentheses times 4 plus 3 squared. You'd use order of operations to make that 3 times 4 plus 3 squared, then 3 times 4 plus 9, and 12 plus 9 for a grand total of 21.
What is a function? It's a set of numbers in the x domain that do not repeat. The x list is obviously the domain, and the y list is the range. It can repeat numbers, and its characteristics are the vertical line test, and it can only touch once. And relations are a set of input and output values. Some characteristics of that are ordered pairs, graph points, and coordinate planes. This is an example of a function.
Inequalities. These are what make our life easier. You have many different signs. You have the less than sign that points this way, kind of like this. You can have greater than sign that points like this. Or you can have a greater than or equal to sign that has like this, with the line underneath. Or you can have a less than or equal to sign with a sign like this, with a line that's horizontal under it, like that. If you have a greater than or less than sign, when you graph it, you must use a closed dot. If you have a less than or greater than sign, you have to have an open dot. An example of this would be 2x minus 3 is greater than or equal to 3. First, you would add 3 to both sides to get rid of the 3 on the left side. Then, you get 2x is greater than or equal to 6. You'd have to divide by 2 on both sides and get x is greater than or equal to 3 and a one-eyed squid. That's about it.
Slope is the rate at which a line rises or falls on a graph. Slope is also known as rate of change. The equation for slope is y2 minus y1 over top of x2 minus x1.
This is an example of a graph with the coordinates 3, 3. You have to rise up and run out.
The wonderful Mrs. Shoemaker showed us a fabulous video of slope that is related to real-world situations called The Adventures of Slope Dude.
Slope Dude's adventure started whenever he was skiing up a hill. As he skied up the hill, he said, puff, puff, follow.
His adventure continued skiing down a hill, which he said, nice negative.
He then continued in a straight line on a nice plane and said, this is zero fun.
And then he hit a cliff and went straight down. And he said the worst curse word known to math. He yelled, undefined!
And that is slope.
We are discussing x and y intercepts and graphing lines. The x-intercept is where a point meets the x-axis. The y-intercept is where a point meets the y-axis. When you're trying to find the slope-intercept form, you use the equation y equals mx plus b. In this equation, m equals the slope, x equals the independent variable, and b equals the y-intercept. Therefore, the y-intercept deals with slope.
Okay, so we made a slope and the y-intercept crosses on the y-axis and the x-intercept crosses on the x-axis. And people decided to make little arrows that show that it goes on forever.
I hope you all have enjoyed this video and...
Algebraic expression. A problem with letters and numbers without an equal sign. A variable, a letter that represents a number.
Evaluate given a piece of information, simplify expression only. Solve finding information.
Expression with no equal sign. Equation has an equal sign. 13 times n equals 39. N equals 3.
The answer's 12.
No, it's negative 24.
Negative 7.
5.
Q.
Q.
W.
Hold on. Do you guys use your order of operations?
No.
Nope.
You never heard, please excuse my dear Aunt Sally?
That you don't have an Aunt Sally.
Well, no, I don't have an Aunt Sally. It's inquired. But basically, the order is parentheses, exponents, multiplication, division, addition, and subtraction. So why don't we work this out? Okay? It's not just throwing answers. There's the problem on the board. We already solved it.
The answer wouldn't be shoe.
No, it's not shoe. Answer is 39.
Okay, Lieutenant Favory, point at the function. Do you even know what a function is? Point at it. Okay, then, yeah, that's a function. Put your finger up more. No, right on the dot, like the dot there. Yes. Okay, now put your finger on the known function. Yeah, look at that. Yeah, it's 3 points. It goes through the line, and there's a line there. It goes, but the other one is only 1 point. 1 point. Do you even know what you're pointing at, Favorite? Yeah. So many points.
Adding expressions. Yoshi combined like terms. The 3 has an x and the 2 has an x. So you 3x plus 2x. And then you do plus 2, 2 plus 1, you get 3. And then your answer is 5x plus 3.